This is another mixture problem involving distance. Jack leaves his house driving 50 miles per hour to go to visit Mark at the hospital. Karen leaves her house at the same time, driving 45 miles per hour. She lives 5 miles farther away from the hospital than Jack does, and she arrives 20 minutes after Jack. How far away does Jack live from the hospital? Okay, so I've got to do my problem setup and define my variables for each trip. And for this problem, I'm going to use a distance picture and a timeline. So here's my distance picture. Jack leaves his house and drives to the hospital. The problem says that Karen lives 5 miles farther away from the hospital than Jack does. So Karen also drives to the same spot, but she lives 5 miles farther away. So Karen can start back here. There's a difference then of 5 miles between these two lines. So if I let Jack's distance from the hospital be represented by X, then Karen's distance from the hospital is going to be 5 units more than X, or 5 miles more than X. So Jack's distance is X, and Karen's is X plus 5. Now Jack is able to drive 50 miles per hour. Karen is only able to average 45 miles per hour. All right. Now, let's draw a timeline for what's happening in this problem. It says that they leave at the same time from their different homes. So Jack leaves and Karen leaves at the same time. But it also says that it takes Karen 20 minutes longer to make the trip. So Jack gets there then, but Karen arrives 20 minutes later. So this time right here, between the lengths of these two lines, is 20 minutes. That means that if I let Jack's time be y, then Karen's time is going to be y plus 20 minutes. So Jack's time is y, Karen's is y plus 20 minutes. Now, here again, we want the units to agree. And since we have miles per hour for our rates, we want this to also be in hours. We want our time in hours. So 20 minutes is 1/3 of an hour. So we're going to have to put y plus 1/3 right here. Okay, that's my problem set up. Now I'll write my two equations and solve them. So using distance equals rate times time. Jack's distance equals his rate times his time. Karen's distance, x plus 5, equals her rate, 45, times her time. So I have two equations and two unknowns. I have to put them together using substitution so that I can solve for my unknowns. Since x equals 50y, I'm going to put 50y in here. So 50y plus 5 equals 45 times y plus 1/3. All I did was substitute the 50y here for the x here. Now, when I do my algebra, the first thing I'm going to do is use my distributive property. I get 45y plus, now 1/3 of 45 is 15. All right, so I'm going to subtract 45y from both sides. And I get 5y plus 5 equals 15. Now I'm going to subtract 5 from both sides. And I get 5y equals 10. Divide both sides by 5. And I get that y equals 2. Now y is a time. In fact, it's the time it takes Jack to make this trip. And since my time is in hours, then y is 2 hours. It just so happens that, though, the question is how far away does Jack live? So they didn't ask about time this time. Instead, they asked about distance. How far away? That's the distance. And it's how far away does Jack live, not Karen. So Jack's distance is x. That means I have to find x. So I'll put the 2 hours into this equation. I could just as easily put it into this equation to solve for x, but that's a much more complicated equation. This is a much simpler equation. So I'll put my y into this one, and x equals 50 times 2, or x equals 100 miles. And then this is what answers the question in the problem. It's always important when you finish doing the math and getting an answer to a variable that you go back and you read the problem and you answer the question being asked in the problem.